Welcome back everybody to this, the first of a new wave of tutorials for the channel, full 3D projects for you to enjoy, starting with this, our Starfox inspired rail shooter series. Best of all, you can download the project files from the link in the description below, including all the 3D models and the boss designed by you, our community, so that you can follow along at home. So, when you're ready, check your G-diffuser systems. Let's crack on. First up, let's talk about the ship setup. Everything will be a child object of a parent player object that we're going to attach all our components and scripts to. Inside is the player ship model and a child object called emissions. Inside, all the emissions we want for our ship, line renders for the wing trails, and a particle emitter for our ship's emissions. If you want to learn how to make this yourself, please check out our 3D charge shooting tutorial, where we cover how to create a sphere or orb-like emission, but you can choose any type of particle emitter you like for these, that's absolutely fine. Now, with that said, let's go ahead and get our ship moving. So let's go and create a player controller script, attach it to the player parent object, and go ahead and open it up. Okay, before we go ahead and punch in the variables at the very top of the script, I'd like you to make sure that you have entered using unityengine.ui, as later for boosting and braking, we are going to be interacting with a speed meter. So do make sure you have that at the top. When you're ready, let's go ahead and punch in those variables. As this is for our player control, we want our directional input up, down, left, right. That'll be represented via the float, horizontal input and vertical input. We want to multiply those inputs, of course, by a public float of move speed. And just like in Starfox, when we move, the ship tilts slightly in the direction we're moving. In order to do that, we're going to have a public float tilt, a public float tilt speed, how quickly we go into that tilt state, and the vector-free tilt angle that we want the tilt and tilt speed to affect. Once everything is set, let's go down and create a void called movement. For our forward movement along the z-axis, we're simply going to input the top line here, transform.translate in the brackets along vector3.forward, positive on z, via the move speed via time.delta time. Now, for our actual control movement around the screen, that will be a private vector3 movement, and that will equal a new vector3. In the brackets there, our horizontal input and our vertical input on the X and Y axis, and 0 on the Z, as that is going to be controlled by our forward vector here. And we want to update that position, so the transform.local position will plus equal a new vector3, our movement on X, our movement value on Y, and our movement on Z, so that X and Y is affected via our horizontal and vertical input, multiplied by the move speed, multiplied by time.delta time. That's all we need for the basic movement. Now, let's go ahead and create a new void called handle tilting below. Handle tilting is where we're just going to manage our tilt Z and tilt X methods. So below, go ahead and create two voids, void tilt Z, and in the brackets, float axis, and same again below, void tilt X, float axis. This is the tilt for when we're moving left and right. This is the tilt for when we're moving up and down. So we're going to rotate on the X and rotate on the Z. Inside Z, let's go ahead and punch in our lines of code. We want to affect a vector3 called target Euler angle. That'll equal transform.local Euler angles. So our current local rotation angle. Then we want to affect that by saying that the transform.local Euler angle equals, and this is quite a lengthy line, feel free to hit shift after the comma to arrange it like you see on screen. And that will equal a new vector3 target Euler angle x, comma. Then for y and z, we're going to have mathf.lerp angle, and that'll be our target Euler angle.y. The axis float we have at the top there, multiplied by our tilt value, and then how quickly we're going to get into that tilt state, the tilt speed at the end, and then we're going to do the same below, mathf.lerp angle, target Euler angle z, minus the axis value multiplied by tilt, ending with the tilt speed. That's all we need for Z. Now let's go ahead and repeat that in tilt X, but we'll change a few variables around. So here in tilt X, we're going to repeat the same. It will have a vector-free target Euler angle equal transform.local Euler angles, but this time our local transform won't be as extensive. Our transform.local Euler angles will equal a new vector-free mathf.lerp angle, and here we're looking at the target Euler angle X minus the axis value multiplied by tilt and tilt speed, then followed by just our current target Euler angle X and target Euler angle Z that are determined in here. Once everything is set, let's return to our handle tilting method, and here we're going to punch in our tilt Z, and the axis will be affected by our horizontal inputs, so our horizontal input value moving left and right, and tilt X by our vertical input moving up and down. Then in fixed update, if you don't have this here, go ahead and create one yourself. This is where we're going to put in our movement method. I found that this just gave a much smoother movement. I tried different methods and they all ended up a little bit jittery, but this worked for me. Let me know how it works for you in the comments below. Then go to update and let's punch in our handle tilting method like so. And let's go ahead and punch in those inputs, which I'm sure you'll be familiar with now. So just above handle tilting, punch in horizontal input equals input.getAxis, and in the brackets there, make sure the spelling is correct, horizontal, and likewise below, vertical input equals input.getAxis, vertical, and that's all we need for our movement input. Hit save, let's head back into Unity and put it to the test. Back in Unity now, let's go ahead and punch in some values for the player controller in the inspector. For move speed, I found that 15 works quite nicely. For the tilt, let's say we want to tilt an angle of 30 degrees, and we want the tilt to be quite fast, so my tilt speed is 0.1. So, when you're happy with your variables, go ahead and hit play. And you'll see that the ship flies and tilts, looks pretty good, but the camera is left behind. We've got no camera follow. So let's go ahead and fix that. Back in Unity, go ahead, create a camera controller script, attach it to our main camera, and open it up. For our camera follow script, it's going to be quite familiar. It's one we've done before in the past, and we want a target transform for the camera to follow, represented by our serialized transform, the player target. How fast is the camera going to keep up with that target? That will be our public float smooth speed at 0.1f, and for a little later, we might want to change the offset of the camera, its position behind the player. So we'll have a public vector-free called offset. The camera is going to be a stationary object, so we want to make sure that we have a vector-free velocity, and that'll equal a vector-free.0, meaning that it's going to be 0 on x, y, and z. And we also want to clamp the camera, so we'll have two serialized floats, one representing the minimum position x and the maximum position x, and likewise for y below, min position y and max position y. Then let's go down and create a void fixed update for smooth movement, as this will run several times a frame in fixed update. And we're going to set a new vector free, the desired position. That's going to be the position we want to follow, and that is our target transform, the player target dot position plus the offset, the value the camera will be behind the player. In order to smoothly follow the player into that new desired position, we'll create a new smooth position, and that will equal a vector-free.lerp. We're going to linear interpolate between the target position, the current position of the camera, and the desired position to follow the player by its smooth speed. So it's going to smoothly keep up with the player and update its transform, which we have to set below. So the transform.position will equal that new smooth position. And we also want to clamp the camera within a boundary we set via the minimum and maximum values on x and y. Therefore, the transform.position will equal a new vector free in the brackets for x, mathf.clamp, smooth position.x by the minimum and maximum position on X. Underneath, for the Y value, mathf.clamp smooth position.y by the min and max position on Y. And as we're not going to be changing the Z axis, that can remain as transform.position.z, as that's what's going to be following the player along Z. As we've now clamped the camera movement, that doesn't prevent the player from flying off screen. So I think it's worth that we go back into the player controller and also clamp the player to the camera boundary. Let's head into the player controller script, and below where we had tilt Z and X, we have clamped screen. In there, we're going to have a vector-free position, and that will equal the camera.main.world to viewport point, the transform.position of the player. And we'll have a position.x, that'll equal mathf.clamp01. This means it will return a value between 0 and 1. And in the brackets there, the position.x, and underneath the same with y, position.y equals mathf.clamp01 position.y. And then the transform.position will equal that of the camera.main viewport to world point, the vector-free position. And we also have to go ahead and add this into the update as well. So let's just put it underneath handle tilting. There we go. Now let's go ahead, back into Unity, hit save and check it out. Select your camera and note the current transform of the camera is -10 on Z. We're going to use these values for our camera's offset. So let's go down to the camera controller script. We want the target to be the player. Let's go ahead and drag the player in there like so. We have our smooth speed already done, 0.1. And as for the offset, I want -10 on Z. And we'll add 1 on the Y, and we'll leave that as is. As for the camera bounds, you can play around with this for whatever you like. I found that a minimum of 5 on X, maximum of 5 is okay. And on Y, -4 and +4. Works for me, but go ahead, play around with this, get creative. And when you're ready, let's go ahead and hit play. And now our ship can smoothly fly through the air, tilting in the direction of its movement within the camera boundaries. If we fly to the highest point, there we are, we cannot move beyond that point. And likewise with top, down, left and right. And there we are, guys. We got our ship moving and grooving. Play around with the values to your heart's content. Whatever project you want to create, you do that. And in the next video, we're going to have a look at some more advanced maneuvers like leaning and barrel rolling. So do look forward to that. Thank you all very much for watching, guys. I appreciate it. And I will see you in the next video. Take care.